into city planning and things like that.
Yeah.
I had the planning department.
Yeah, and also we have Dr. Vincent from PSNA, one of the universities in southern India. Vincent?
Hello, sir. Yeah, sir. Good evening, sir.
Yes,
good
sir.
Evening.
Yeah.
Yeah. Good evening, Clarice. And hello, Dr. Gayatri. This the PSN Engineering College is situated near the South India, and we are working on the artificial intelligence and data sciences courses we have introduced this year in our institute, and we got the NB accreditation and as well as the NAC accreditation process. So all our departments are the research center. We would like to collaborate with Mr. Ganeshan Narayanasamy for the long time. And thank you for giving the opportunity to join with you, sir. Please, sir. Yeah.
Thanks, sir. Thank you, Mr. Vincent and Mrs. Gayatri. Thank you. Okay, so yeah, let's give one more minute actually for session to join. People to join. Okay, interest of timing, let's get started, Clarice. I'm sure the people will join as we start our program. So welcome to our Open Power Academy and Research webinar. Thanks for joining today's webinar, and my pleasure to have you all here. Today's session is on AI in enterprise at scale. And I have my colleague, Clarice Edgelin, who is a AI architect worldwide, going to be presenting about the AI, all the features in the enterprise at scale. Definitely, this is going to be a very interactive session, as we have two panelists already joined, and some more will be joining a little later. Clarice, please go ahead and start your session.
Okay, hi everyone. I'm going to stop my video in case of bandwidth, and then get started.
Yeah, the video is good.
Okay. All right, so I'm going to talk about AI in the enterprise at scale. And we're going to start about talking about how the state of analytics is today. And then we'll cover the AI ladder and life cycle that IBM has developed and is pretty common across the industry. We'll talk about some of the themes that keep coming back when you're trying to deploy AI at scale. And finally, we'll talk about some infrastructure considerations. And throughout, I'll include some use cases and some examples of how we've helped clients with along their AI journey. So today, most customers do data analytics using either tools and applications that they've built themselves, or they're using packaged tools, or in some cases, they're not at that level of sophistication, and they're using basically ad hoc techniques and spreadsheets and collecting data somewhat randomly and not very organized. But in terms of advances, most AI, most systems for analytics prior to AI were using business rules and based on the patterns and rules that were developed looking at information. With the advance of machine learning and deep learning and AI in general, there's capabilities to do more along these traditional data analytics techniques and move on to this next level of modernization. So in terms of what I mean by that is when we talk about analytics, our first instinct is to look at what has happened, and that's a descriptive analytics is what we call it. So you're looking at data that you have and you're evaluating the information. At that point, you want to go into predictive analytics and go and explore what will happen. At this point, you've got data, but you're starting to also have human input and analysis that goes into this. And the goal is to go from data to insights to actions. So the next level is prescriptive, what should we do? And finally, cognitive, which is, can we build a system that learns from this and does the insights and develops insights more dynamically and with less and less human input and intervention. So let the data speak for itself and only at the final steps determine based on the automated insights that you get what actions to take. Some common patterns of analytics that you'll see are and types of activities include forecasting and budgeting based on past activity, understanding of past activity, as we mentioned, predicting future events. This is where you've got the new techniques that come in that include deep learning, supervised and unsupervised machine learning and other techniques. And the idea is to discover insights from not just traditional data, but also more unstructured data like images, videos, sound, things like that. And that's where natural language programming can come into play. And then finally, based on all this insight, what should we do? So solving challenges with data and AI will utilize a combinations of these patterns, whether it's feature engineering and machine learning, or simple spreadsheet decision trees, things like that, or advanced deep learning techniques. Depending on what your data looks like and what outcomes you need, you'll determine what algorithms make the most sense to get your analytics projects going. So relative to the adoption of AI, we see three broad categories of use cases. The first category is more aligned around structured data. This is more what you're used to in traditional analytics with input coming from databases, for example, organized in rows and columns where you've got features and labels for your data. There's been a lot of techniques and algorithms that have used AI for insights from this, and it's really the starting point for a lot of the early AI adoptions. Then you've got computer vision use cases, and this has really exploded since the early 2010s because of impact relative to algorithms, with AlexNet, for example, winning a major competition where vision ended up, the machine vision ended up being more accurate down the road than human vision. And so that's been a breakthrough from an algorithm perspective. And the other breakthrough reason here is because you had more access to compute capabilities than you ever did before. And so now you can train extremely large models that learn through these vision categories. And that adoption of technology plus algorithms plus the explosion of data that we're seeing in the last couple decades has really made computer vision use cases very attractive to businesses. And then finally, a category of AI that we're seeing, and you see this every day in your on the internet with chat bots and automated translations, things like that. This is the category of natural language processing. So here your AI is learning to read and interpret language. As I mentioned, the AI techniques that we talked about, those three broad categories, are happening across the board in all industries. We see, for example, in banking, techniques, advanced AI techniques for fraud detection. In the automobile industry, we see safety, manufacturing inspection, process improvement, of course, automated self-driving cars, things like that. And then defense and security, we also see a great adoption of AI with things like facial recognition, anomaly detections, things like that. So this is just three categories in industries, but any industry that you come across, you're going to find innovative AI techniques that are being developed in agriculture, in consumer retail industries, in utilities, prevention of wildfire techniques out in California is a project that we worked with and to have them adopt AI techniques to improve the outcomes there. So really across the board and having a worldwide impact on the techniques that are being adopted. Oops. And as you know, AI is the fastest growing workload. Forrester Research has that developed and proven, and we have a lot of information on that across the board. So IBM's perspective is to look at the AI ladder, and it's really adopted commonly in terms of thinking about data first and having good data to get started, collecting and organizing that data. And then eventually, once you've got data and you've prepared it, you can build models and analyze the information that you're getting from your data. And finally, once you've got models that reflect the accuracy and the goals, your business goals developed, you can deploy or infuse them across all your business areas. And so the idea here is to operationalize your AI at scale. For all of these, you'll need data information of every type and be able to access it wherever it lives. And you'll need an optimized infrastructure to develop and build models. So this is what we call modernizing your business systems and taking an AI ladder approach to that journey. So as I mentioned, data is a prereq to AI. To really leverage the new developments in algorithms and the compute capabilities that are available, you really have to start with data. As I mentioned, those data sources come from, can be many different types of data coming from many different sources. So you have operational transactional data from your databases, your sales records, things like that. You've got sensor data, machine data. This could be images that come from cameras and other sensors, geospatial data, social data, third-party data like weather data, for example, might feed into some of your AI models. You need to be able to govern all this data, and that comes from many different sources. And when you look at AI in the enterprise, there's a lot of coordination, integration, and workflow management that needs to come into play to get from the data sources to on the right-hand side, the types of applications that you feed your AI in. we mentioned chatbots, personal assistants, optimization of supply chain, recommendation engines, pricing engines, looking for anomalies, risk, fraud, building autonomous systems, and modeling behavior. So all of those applications need data. Digging in a little bit deeper in terms of what we need and what we need by data sources, we start with ground truth when you want to build a model. Ideally, for supervised model building, you need to have a ground truth so that you can evaluate your models against that ground truth. You need subject matter expertise and domain knowledge. So this is the type of data that typically is proprietary, but could also be shared across researchers, for example. And that's the expert data that you bring to the table to customize your models. Private data versus proprietary data are two distinctions on where to find the data and how to store your data, maybe possibly, and how to secure your data. There's personal public data and public data. This is information that you can get publicly. And finally, purchase data, where it's companies and third-party organizations provide data to you. So this data pipeline is important because it's not sufficient just to have the data. We talk a lot about data lakes, but sometimes those turn into data oceans, data swamps, where there's not a good architecture for your pipeline for AI. And so this is our perspective of putting a structure around your data. So you are going to have data at the edge. So this is data that you're going to ingest. And from that data, eventually you want to get insights out. And through that, if you go through the steps of the ladder, we talked a little bit about collecting, organizing, analyzing, and infusing or deploying. You're going to look at your storage and your data and how you're going to manage it and what kind of requirements you're going to put on that. So from the sensors and data that you have, you may have some ingest requirements. So in that case, you may need some transient storage and a temporary landing zone. And you may need to ingest real time or in bulk, in batch. So depending on those requirements, you may need a lot of capacity for your storage, or you may need a lot of performance if you're doing near real-time ingestion, for example. Once you have that data ingested, you may need to have some traditional transformations like extract, transform, and load to your data. You may need to do some data prep specifically for modeling, like augmenting your images for a deep learning model and labeling your objects or your classifications that you want to model. And there's also potentially information coming out of your metadata that you want to save and feed into your models, like geospatial information or categories of where and when the data was collected, the size of the data, things like that. So metadata can play an important role in the organization of your data. Once you've got that data prepared, organized, and stored the way you want in say, a data lake or Hadoop file or generalized parallel file system, you're going to pull that data in to train your models or feed your applications and your simulations. You'll get insights out and feed that information back in to your models. And so you're storing not just your initial data, but the data that you're generating and that you're collecting as you build these models and, more importantly, deploy them. You'll also want to think about how you archive all that information. and we'll talk a little bit about model trust and explainability. So having a good system for archival, whether it's tape archive or object storage archiving, having enough capacity to be able to access your data, and even older stale data can be important as you go through these use cases. So a little bit more about metadata and having the right tools to automate the discovery of your data and collecting your data. These are some of the things to think about as you're looking at that. Is, do you have a good set of APIs to access the information? Can you scan your data fast enough that you're getting this metadata information fast enough? Is there automated indexing? Is there capability to tag your data, either custom or auto-generated tagging? And do you have workflows to capture and report on your metadata? So taking a closer look at the actual model development piece, we talked a lot about the data prep and that stage, being able to clean, label, and have a good collection of data. You'll then move into the training stage. This is where you typically would like a workbench so that you can have a place to generate models quickly and evaluate them quickly and adjust them as you need. This tends to be done by data science teams and in combination with the data engineering teams that are helping feed the right inputs to those training efforts. We'll talk a little bit later about kind of the forces that come into play for training. Here you may need very fast compute technology, and you may also need parallel applications to train if you have performance restrictions in how long your models take to train. Once you're happy with your model and you've got the right metrics in terms of accuracy and usefulness for these models, you go into the inference or the deployment phase. And here it tends to move into more IT operations and productization of the models. So what we just described above in terms of understanding your business, doing the data prep, visualization, modeling, evaluating those models and deploying, is actually, when you look at AI at an enterprise scale, is in fact just a smaller piece of the bigger picture. In terms of building a model, and that's somewhat the fun part of building of AI, because that's where you're exploring new algorithms and seeing that it really works. But you do need a whole infrastructure and management system and governance to get to that deployment at scale in an enterprise. So from overall perspective, you'll have additional pieces and components that come into play that that look at more of the data side in terms of how you're collecting the data, how you're configuring it, how you're verifying it. You may have teams that are doing additional feature extraction and additional data prep. You may need tools to manage all of the models and analyze all the models. You may need to have a way to deploy the resources for the training and the inference. And so you'll need to also be able to monitor and have infrastructure for services and storage. And across the board, security, privacy, and governance come into play. So this is just to say that we tend to speak a lot about model training and inference, but when we talk at an enterprise level, we need to be talking about deployment, going into production, and having all the pieces come together for a a solution that you can trust. So when we look at model quality and how to build models, I mentioned a couple times already that it's an iterative process, and there's some challenges with building quality models. One is having enough information to build a good model, having enough resources and using those resources efficiently to build your models. There are concerns in terms of complexity and workflow. In many cases, you need an ensemble of models and being able to feed one model into another and so on. So there's certainly some levels of complexity as you go through your AI journey that come up. And then finally, being able to trust the process and the outcomes of those models. So these are all things that we look at when we work with clients in terms of what their goals are and what their desires are for these areas. And that can define an infrastructure as well. When we talk about trusted AI, we think of these types of questions. Is it fair? Is it easy to understand? Is it secure? Is it accountable? And when you build a model, you want to be able to have, be able to stand up in front of your stakeholders and say, I can explain how this model works, why it works. I can confirm that I used fair data and unbiased data to train my model. I can confirm that my model is not subject to adverse changes where, for example, a slight change in input results in a very large change in outcome and attacks, of course. And then, is it transparent? Is it accountable? And can we replicate the findings that we have, and can we explain them? So these are things to look at when you're building at a larger level and you move beyond the proof of concept or just the small model to test that it works. So let's talk a couple examples. These are some examples from the life sciences industries. The first example is medical diagnostics using medical imaging. There's some advantages to having a system augment what a radiologist, for example, is looking at relative to medical images for diagnostics. One is that it can improve the accuracy and give the subject matter experts some additional insights into what they're looking at. It can reduce fatigue, human fatigue, because it's more automated, obviously, and it can create less individual error and have more consistency. So there's a lot of interest in automated medical imaging. And of course, the goal is to reduce the false negative rates in clinical settings and reduce patient and medical legal risk. So some examples of that would be, this is an app that actually was developed in our IBM Israel Haifa research lab. And it's a portable system that can take an image of a skin lesion and determine whether it can predict whether it's a melanoma, atypical or benign, and provide a prediction of and recommendation of a follow-on. And so this is nice because it comes a lot faster than your traditional information. And so the model is basically trained to recognize the differences between these images. And they're just, iPhone or some other device images that you can take in the client setting right off and the patient setting right then and there. Another example is a 3D UNet model that looks at brain tumor segmentation. And so this is a different type of image, but it's the same idea, different type of model to detect the finer points of a brain tumor and the structure of a brain tumor. And then a third example is a blood sample on a slide and detecting what the characterizations are to classify the blood cell subtype. So this technology, AI technology, was used at Vanderbilt School of Medicine and Washington University in St. Louis. And they were able to train images 20 times faster than what they were doing prior to infusing AI into their workflow. Another example relative to life sciences is a partner of ours called Novi Systems built an appliance that takes the data and from different sources that we talked about earlier, applies different types of models in what they call data fusion, and comes up with an appliance that, based on fact tables and insights that it generated from these AI and traditional analytics models, can answer questions. And so it built this it can build this for a lot of different industries and clients. But in particular, in the early days of COVID, it built a system that was exploring medical publications in an automated way. And you can go to their website to learn more. And in fact, I believe they have a system that's up and running that lets you look at active COVID information through this AI appliance. Another use case tied to molecular simulation, which you might say, well, that really has nothing to do with AI because it's traditional high performance computing simulations, number crunching on data. But in fact, we're using AI to find a better path through the next best simulation to perform. And so what this is doing is, instead of using brute force or a system that's not looking at information from past simulations to develop what the next best simulation should be, to accelerate how many simulations needed to get done overall to get to their end results. And with this technique, using a Bayesian optimization, so a new product that we just came out with called Bayesian Optimization Accelerator, we were able to do molecular modeling at what the humans were taking were months, and reduce it to days to get to a result. We've also done this and demonstrated this, for example, with a Formula One car design, where we could show that the design could go from months to weeks, and be able to look at more options in a shorter time frame. Another use of AI. Another example is with cryogenic electron microscopes, and this addresses the AI piece, but also going back to the data. How do you manage all this data that is just generating so fast, so much these days? And this is a use case of an application that does image recognition on the output of these cryo-EMs. And the amount of data that's generated per day on average for one of these very expensive systems, microscopes, instruments, is 5 terabytes of images per day. So their challenge here was keeping up with being able to analyze that much data that quick. And of course, storing that much data, because as you can imagine, this is all medical information that you need to store and keep. So we showed that a system that we have installed at MIT, I believe it's a 64 node cluster, was able to run 100 of these Insight workloads for the cryo-EM in parallel on this cluster. And of course, that leads to faster time to science, and that's the goal. All right, so that kind of covered a little bit the why we're here in terms of AI relative to the data and the modeling and some of the use cases. And again, I picked one industry, but you could find 3 or 4 use cases to highlight in every industry of interest. And we'll switch over to talking a little bit about more about what it means relative to infrastructure and some of the components that you need to think about as you're building an AI infrastructure. So the wrong infrastructure puts AI at risk. What we've seen, of course, is having sufficient pipeline because of the data and the compute intensiveness of the training in particular. We need systems that scale, storage that scales to meet demand, and processors that are optimized for the types of workload that are happening in AI. So we talked a little bit about this from a data perspective. Again, having access to data that you can scale and see quickly, having a tiered secure infrastructure is a goal. And depending on what phase you're in your AI model usage, you may need more bandwidth, or you may need low latency, depending on the piece of work that you're looking at. And by that, I mean for training, you tend to need high bandwidth and low latency. But on the inference, that's really the key, is advanced I/O with minimal latency, because you're going through, your model is trained at that point and you need results from your model as quickly as possible. So an enterprise view of what your AI system might look like is going to have a lot more than kind of what we talked about right now, which was the data science workbench and the having the capability to scale out via an AI set of servers and storage, possibly organized in a grid or a cluster. But there's a lot of pieces that come from the data relative to the information that you need. So you may have in-flight transactions, IoT information. You may be pulling information from operational databases or modern databases. You may be pulling things or saving things into data lakes. And a lot of this tends to happen on-premise, although we see a shift of course, with hybrid cloud, where even the data can be a combination of on-premise and on-cloud storage and compute. And then we see on the other end, being able to deploy your models everywhere. So whether it's on devices, in the cloud, on servers, on embedded technologies. And so all these pieces come together. And the point here is that you may have some information that's on premise in a data center that you need to pull in. And you may have information that may be on a private cloud or a public cloud. And how that differentiates definitely moves depending on your requirements and your goals from a business perspective. And we'll go through a couple examples like that. So a little bit more on the inferencing side. Again, this is when you've got a trained model and you're generating data. You'll have the data center option. You'll have near edge inferencing, which is possibly smaller systems or distributed systems, where you'll have a different set of infrastructure considerations to take into play. Or you'll have some of the inferencing which is actually happening independently in the sense of the data center, and that's happening close to your to where you need your information. So obviously a typical example is for self-driving cars. If you can't inference what you're seeing right there, you can't have a self-driving car. So you have to have all those decisions happening right there at the edge. So the types of things that come into play, and of course accuracy is a big one and is far-reaching. Different models and different scenarios, different use cases will require different accuracy. And by accuracy, I mean all the metrics that you may look at. So you may be more interested in false positives than true negatives or something. So depending on what your business calls for, your metric for accuracy may be different. So you'll factor in real-time versus batch requirements, how much you need to scale, where your data is coming from, how much security you need, how many other applications and groups you're working with. So multi-tenancy, when you get to scale, is very important. Ideally, being able to leverage the same resources and consolidate is a very nice feature of some of the tools that offer that multi-tenancy. And you'll also want to see how you organize all of these components. We see a lot of tools proliferation and having some level of reuse and consistency, even if it's just from a language perspective, in terms of definitions of what your models are doing. You want to factor that in, and that goes along with model management and as well. Ease of deployment, and we talked already about trust and explainability and transparency. So here's an example from a manufacturing use case of where it's not just a single model, it's a collection of models that come together for this manufacturing company. And what we started with was a proof of concept in a single factory location on a single line on a single component. So built an AI model that detected a loose cable using cameras right on the edge, automated auto ML tools to build a model quickly and deploy it. And from there, built additional models for that assembly line at different stations of validation and inspection that they were interested in. Then built some models that looked at optimization and other factors that were at play in the factory. That was consolidated at a factory level. And then across multiple factories, multiple assembly lines. And now we had a need for feeding systems back into headquarters and building dashboards for quick decision-making and coordination between the factories, excuse me. And then finally, deployment within data centers, local to the factory floors, on the cloud, and at headquarters, the larger data centers. So this is an example where a lot of different pieces can come together and what we mean when we talk about AI at scale for the enterprise. All right, we're talking a little bit about technology here in terms of picking the right infrastructure. So one piece of that is the server and the CPU for training. You may have interest in GPUs for training. We're pretty excited with our Power 10 family that's coming up, with some specialized instructions that are in favor of the types of calculations that machine learning and deep learning models do. We've had a consistently good story with always pushing ourselves to the next generation of technology, and that's where Open Power and the IBM Power technology roadmap will take you. Open Power, as I mentioned, has access to the architecture, the Power architecture, and there's a lot of innovation coming from third parties, and there's a lot of opportunity for innovation through the Open Power Foundation. And I'll just point out a specific offering, oops, goes very fast, from Open Power Foundation called OpenCE. And this is basically fine-tuning open source packages like TensorFlow and PyTorch that are used very commonly in machine learning and deep learning, and making them available on the Open Power architecture. And easy install, easy setup. And so you can be up and running to build a model in no time with this type of package that helps you work through all the prereqs. And if you've ever tried to build from scratch TensorFlow, you may know how painful that is. So it uses Conda as well. And so there's really the best available for automated package installation and to be up and running as efficiently as possible. Another very interesting development relative to open source is we are seeing more and more deployments that use Onyx. And this is basically a common tool that allows you to take models trained on different platforms and different techniques with different frameworks, translate them into this common runtime, and deploy across multiple architectures seamlessly with very little effort and customization. So we're seeing some of that pattern. And the idea is you can train with any framework and run with Onyx on any platform. So it's really pulling together the training and the inference and making infrastructure platform decisions simpler, because now you can mix and match as needed. We talked a little bit about cloud. I wanted to mention a couple more things relative to that and how we're viewing that in relative to hybrid cloud in particular. So cloud native platforms is basically talking about using microservices, containerizing workloads, and being able to provision across multiple cloud locations, whether public or private. A lot of this also has to do with automation. Ansible and Terraform are some of the components that we use a lot. We see a lot of OpenShift and Red Hat OpenShift deployments for provisioning and making all these resources quickly accessible in the cloud. So this is a trend that we're seeing in AI as well. And as I mentioned, the hybrid cloud trend is at play as well, especially for clients that do have large data centers and have secure and confidential data on their on-prem systems. But we do see a lot of movement towards the cloud and hybrid deployments where some pieces are in the cloud and some are on-prem and some move back and forth based on demand and capacity requirements. So we have on-prem and private cloud capabilities. I mentioned a little bit about some of the tools like Ansible, and in particular for power systems, we have infrastructure as a service through IBM Power Systems virtual server capabilities on the IBM public cloud, and we have availability as well on on-prem cloud, and we support AIXI and Linux images. So going back to our analytics discussion, we talked a little bit about machine learning and deep learning and the fact that a lot of the analytics take place even broader than AI. Here we'll go through a couple examples relative to, I'll pick SAP HANA and SAS Viya as some examples of how they are deployed on power systems and some of the advantages, and just give that a broader perspective on that. So this is a SAP HANA use case. So a company was looking to come up with a better solution, and so their use case was an on-premise consolidation, and they wanted to have an impact on their environment, on the environment, by consolidating and using fewer resources, and they were able to reduce their total cost of ownership by a factor of 3 by consolidating using virtualization, and they were able to reduce their carbon footprint. Another SAP HANA example was a case where they were looking to take advantage of IBM cloud and move out of an on-premise data center. And so they used the IBM Power Virtual Server and were able to migrate 16 LPARs with almost 300 terabytes of storage in tier 1 and tier 3, and basically have a very smooth migration process going from their data centers to their public cloud Power Virtual Server infrastructure. So when you run SAP HANA on IBM Power Systems, you're providing, you're able to provision faster, scale affordably, and maximize uptime. So there's a lot more information on this if you are a SAP HANA client, and we would encourage you to reach out to us to learn more about that. Relative to SAS Viya, which was another scenario of analytics that is marching into the AI world, is SAS Viya. So this is an all-in-one, built-in, inclusive way to manage your AI. So the AI pieces that are introduced are actually built in to the SAS workflow and infrastructure that you're used to. So it provides an engine for analytics, and it leverages in memory for performance, and of course Power Systems excels at that. And really, it's different from a lot of the smaller startups. It's got a long history, and that is because it's able to handle very, very large quantities of data. So they have figured out the scale piece of advanced analytics. So a lot of clients come in from SaaS as SaaS clients. SaaS Viya is a new offering from SaaS that offers more of this AI and modernization technology that SaaS clients might be interested in. They complement each other. They're not necessarily a direct replacement. One of the more popular components of that is the SaaS Visual Analytics. Again, it allows you to solve difficult problems at very massive scales. It is a great way to visualize your data and hit the business components quickly and efficiently. It has the predictive functions that we talked about and is now using AI under the covers, deep learning and machine learning techniques for that. And it allows reporting very efficiently for being able to make a good case from your data insights. So high performance technologies, accelerated analytics computations, resulting in a lot more insight, a lot faster, and a lot more efficient ways to improve your business. So Agile reduces risks and eliminates bottlenecks when you run on power systems. In summary, gaining insights with AI requires a flexible end-to-end solution-first approach. We talked about defining your AI goals and focusing on solving problems and defining use cases. We talked about knowing your data, where data is a prereq to AI and needs its own architecture and well thought out layouts. We talked about how to build out your workflows and how machine learning model building is just a piece of an overall workflow. We talked about how infrastructure matters and optimizing your infrastructure is an important point in designing your architecture. And finally, we want to conclude with establishing trusted collaborations and partners as an important part of the overall process. All right, so that concludes the presentation piece. I have not been following the chat while I was presenting, but I'll take a look there. And of course, happy to open it up to questions and answer any that I can.
Thank you, Clarice, for the detailed presentation about AI in enterprise. This is very good, actually. There are a lot of things, people can work on, with the data, whatever you provided. So audience, participants and panelists, any questions for Clarice? We have Abhinandan from National Institute of Engineers also joined as panelists. Professor Abhinandan.
Hi, Ganeshan.
Hi. Thanks for joining.
Yeah, thank you. It was a wonderful session.
Yeah, thank you.
Yeah.
So any questions from the panelists? I do see, there is one question in our question and answer window from Professor Gopal. Clarice?
Yes, I'm looking at it now. Measure what is measurable and make measurable what is not so. What are we making? It's a very, very great quote. So what are we making measurable?
You want me to, maybe I will allow him to talk.
Yes, if you want to expand on that.
Yes, sir. Mr. Gopal.
Good evening.
Yeah, go ahead, sir.
Am I audible?
Yes, sir.
Yes. Thank you very much, Dr. Clarice, for a very illuminating lecture. The concern here is that, one, there are several things which are not really measurable. Second, we don't want to measure so many things. So, however, when we talk about blending, let us say what is measurable as quantitative and what we chose not to or not measurable as qualitative, how do they fit in together? And how does it scale? How that blending of quantitative and qualitative blend.
Very, very interesting thought here and questions. So there's a couple ways to look at this. One is it's without measurements, you don't know what you're looking at, right? So there's a high risk if we don't measure when we're building models that we won't know what the quality of our models are. So as far as training a model, we have to have a good starting point and a good base and have access to measurements, things that we've measured. Now, with that said, the outcome of our models, and I think I made the point a couple times, is that the model doesn't make the decisions in the end. It should always be, or as best as be, in conjunction with the human element, and that's where the factors that are outside of measurements come into play, and being able to use common sense or judgment as you leverage these models is really very, very important. It can't be an automated society without that. And I think that's where those decisions relative to not being, not measuring everything might come into play. Also, from a algorithm perspective, there are lots of AI techniques that allow for a lot more flexibility in the sense of how it clusters decision. I'm talking about unsupervised or semi-supervised techniques where you can build models with less data and or let the model somewhat organize the data so that you're not necessarily dependent on labeling everything, for example.
Thank you.
Thank you, Clarice.
I see a question asking from where I am from. I'm in Charlotte, North Carolina in the US. And I'm home because there's nowhere else to go.
Anyway, it's holidays as well. So.
Right.
Sure. And any more questions from the panelists?
I see a question on urban planning.
Oh, okay.
Process. I have not thought of use cases relative to urban planning, although we do have it with, you know, if you gave me 15 minutes, we could come up with some great ideas. That's I think where the field would be. The key here would be to have a subject matter expert in urban planning to talk about, you know, what their pain points are and what matters, you know, what they're looking for. And then I know that from a city planning, there was one of the very first vision models that we developed was to detect double parking in a specific zone, street area. And that would alert someone to go and ticket the cars. So anything that you can see as a subject matter expert that you can make a decision, that you would like a prediction on, you know, a decision to make based on what you see, is a candidate for a vision model. And of course, any kind of data that you have that you want to, you know, find trends on, you have an opportunity for AI as well.
Thank you, Clarice. One more questions from Ramar Bose in the Q&A window.
Okay. Which factors help to measure the quality of a model? Okay. So when we look at evaluating a model, we look at how well it's doing relative to the ground truth. And there are multiple ways to look at that. You can look at how many, so maybe actually probably the best thing to do would be to show you a quick screenshot of that. And see if I can. Anyway, I was going to talk about what's it called? Confusion matrix, where you can look at recall versus sensitivity versus accuracy. And it's all understanding what matters to you relative to false positives, true positives, false negatives, and true negatives. And basically what you're looking at is different metrics that you can calculate for that. But there's another perspective that's of interest. And here is, if I could open up. The other perspective is, oh, I don't have it. Okay, the other perspective is looking at, how much data or how much of the population do you need to look at to come up with better than random guess. And so a model that can do better than a random guess with a small population is very desirable. So that's another way to look at it. And by that, I mean that if you had the answer for 100% of the population, you would have 100% accuracy because there would be no prediction involved. So the more you can predict better than random with the fewer input, the better your model can be. So that's basically how we look at how good our models are. We will do a lot of things to build better model. We look at hyperparameter optimization, looking at all different combinations of parameters, ideally in a smart way, like the Bayesian optimization accelerator that we use. We'll look at whether more data can help. So we have a lot of tools to, especially with vision models, to augment data, whether it's, increasing noise in the data and creating new images, rotating, flipping. So augmenting data and looking at sensitivity of our vision models to more data. There's basically a lot of different techniques, and that's why it's iterative. And some of it is art, some of it is trial and error, and some of it is, knowing when to give up. If you overfit your model, that it's so good with your input data, but it can't generalize, then you've worked too hard on the model. So overfitting, underfitting is also something to consider as you're building your models.
Yeah, this. Mr. Ganesh, sir?
Yes, sir. Go ahead.
Yeah, sir. I think she did a very wonderful presentation. And really it's talk about the AA and a lot of application and the architecture about the things. And how the AI, artificial intelligence, I think we talk about the vision, computer vision and use case, how this could be taken into the real research scenario. How AI will make a augmented reality, whether it's useful, how the IBM is taking care about the augmented reality. Could you able to comment on this?
Yeah, Clarice.
Yeah, yes, augmented reality is definitely a favored topic in IBM research. I don't have on hand some of the specific areas of interest that they're exploring, but I know that it's one of the main areas of research, along with the trusted AI is another very hot topic in research. And then the final one that I know of that's active is how to have better AI models with less data.
Thank you. Thank you very much.
Thank you, sir. Any more questions? Professor Gayatri?
Yeah. Hi. Thank you, Clarice, for the wonderful presentation. On behalf of NITI School of Architecture, Planning and Design, I would like to thank Mr. Ganeshan for this wonderful series of webinars on AI. So I would like to take this opportunity to request to hear more use cases which are related to architecture, planning, and to some extent construction. So if you can arrange for those, it will be more helpful for us on behalf of all the architects and planners present in today's talk. So one question to Clarice is, can you throw some light on the usage of AI in creative fields like architecture?
Yes. So very interesting in terms of creative. As I mentioned, anything that's visual, you can build models that are inspired on that. So for example, we've seen cases where you can take a style and build a model that feeds an image and produces an output within that style. I have seen that with art. You know, you build a model that can do Van Gogh style paintings, and you take any image and your output is a Van Gogh style painting. I would think that in architecture and in design, there may be some very interesting, innovative ways to use AI to build these kind of style models. I don't know if that's a possibility, but that's one that came to mind in terms of creative and artistic examples. The other thing is anything that can be changed into a vision, into a picture, a representative picture, I guess, you could explore. So if you're looking at sound, and maybe, you know, buildings might have sounds or something, you could take those sounds, map them into an image or into a spectrography image, and apply deep learning models to that and come up with some ideas and creative thoughts there. So really, once you understand what the inputs are, and you can look at what kind of data you have or that you could easily generate, then coming up with some ideas, inspiring yourselves on what other industries have used is a good way to let those creative ideas develop.
Okay, thank you.
Thank you, Clarice. So, and one last question, probably, like, you know, if you have some time to address it. It is from Archana, Professor Archana from Architecture Institute, on the question and answer window.
Yeah. So this seems to be tied to some of the comments I was making about IBM is developing tools that let you validate that your models aren't introducing unintended consequences. And so I believe that the AI ethics topic is quite critical, and there's definitely work around those areas on what to do. I know, for example, in the US, we do not do facial recognition projects at this point. So absolutely, making sure that no harm is done is a critical piece to developing AI for good.
Sure. Thank you, Clarice. I hope, I think you addressed all of the questions. And I'd like to thank again, the presenter, Clarice Edgelin, for the wonderful presentation, and also the panelists as well as the participants who have been actively participated in the webinar. And happy holidays to you all. Next 2 weeks, and my advance happy New Year to you all. And looking forward to meet you all in next webinar in 2021. Hopefully we'll have a good set of talks, presentations, virtual as well as the hybrid in 2021.
I'm looking forward to it.
And thanks again, Clarice, the whole team, for supporting this webinar for last several months. Thank you. And
Happy New Year.
yeah, happy New Year. Thank you team.
Very
And
Thank you all.
Yeah, thank you, sir. Thank you, sir.
closing the webinar now. Yep. Thank you.
Thank you so much for this opportunity, Mr. Ganesh.
thank
Yeah,
you very
thank you,
much.
Robin. Yep.
Thank you. Thank you.
Bye.